Hi, time for a really quick chime video. Recently, like a week ago, I posted a two-part video about servicing a NuTone K35 clock chime that was a two-note bar chime. Today I'm working on another two-note chime base. This is a long tube chime base, but it uses a very similar power unit assembly. The power unit assembly are the two solar electromagnetic coils with the plunger inside. And if you go back and look at the K35 video, which I'll put one of those pop-up tags right here, you'll see that they look almost identical, but they are somewhat different. The K35 chime was dated 1956, and this chime is dated 1976. And actually, if you turn it over and you look right there carefully, you can see the traditional NuTone ink stamp, which was not done very well. And it says 76, and it looks like could be B or 8 next to it. This metal chime base, not this necessarily, but the actual part that the tubes hang on, which goes this way. If you look carefully also down here, and I'll try to see if we can get it so you can see it. It says NuTone chime signal made in the USA, and that's the same type of impression that NuTone used all the way back in the late 30s and early 40s and right after World War II in like 1947. This basic chime-based design has been in use forever. So this particular chime base is 20 years after the K35 chime was made, and the power unit still fundamentally the same design, but there are some differences, and I thought I'd show you what those differences are. Taking the power unit assembly off the base to make it easier to show you, and you'll see it looks, if you go back again and look at the K35 chime part 1, you'll see that it's essentially the same. We have 3 terminals on the front of the power assembly. We have transformer in the middle, front on the right, rear on the left. This is a two-note, two-door chime, so front door rings ding dong, rear door just rings ding, and inside we have basically 2 electromagnetic coils. The one on the right, which is longer, is for the front door, and the one on the left is shorter for the rear door. There's a brass tube down the middle of the coils, and this is where the differences sort of begin. On the K35 chime, you have a brass cap on this end and a brass cap on this end. But in this later version, the left-hand end of the brass tube has a formed closure over it instead of a brass cap that's pushed on. And this is just basically rolled over to make a flange. You can see I can put the screwdriver tip underneath it. And then there's an opening for the plunger tip to pop out. And then we just have a single brass cap on this end. Now, one of the things, and this is a tip for people, one of the things about these brass caps, and I addressed this in the K35 video, is oftentimes the original brass caps from the 30s, 40s, 50s, they crack, they split, and usually they split right in this area here because of the pressure on the brass from when it's pressed onto the end of the brass tube. This one is a little different because it has this little flange right here where the early ones don't have that. The early ones is just a straight cap. It doesn't have this bent up flange, and I think the flange was added to make it stronger so it wouldn't tend to crack. One of the things that comes up on these is if you're going to service this and clean the solenoid bore and the plunger and so forth, you have to take the brass cap off to get it apart. And I get these in from people who try to do it themselves, and oftentimes, like this one was, this is pressed on very tightly and it's very hard to get off. And people tend to mangle them up in trying to get them off. The normal way you would start is you would use a flat-bladed screwdriver and you would try to lever it off in different positions and try to scoot it up around and around and around until it pops off. That doesn't always work. And then of course what people do, oh, and when you do that, you don't want to use the fiberboard front piece as a leverage point because you'll crush it and bend it and break it, and that's a problem. So you can't do that. Then what people do is they go at it with a pair of pliers, needle nose pliers. Sometimes they'll take them and they'll put it inside the opening like this and grip onto it and try to twist it and so forth, and then they mangle it all up and bend it, or they grab it around the outside and try to pull it off, which if you think about it is kind of silly, because if you're squeezing it with a pair of pliers to grip it, you're actually making it tighter and then you're trying to pull it off, and that doesn't really work. So how do you actually get these off? Because these are not fastened other than just being pressed on. The way I do it is, and I'll see if I can show you here, is I use my soldering iron and I put the really big tip in it. This is the largest tip I normally use. And basically all I did was I just laid it on the brass, on the flange of the cap like this, and I actually put a screwdriver to sort of hold it down like that and keep it flat, and left it on one side for 4 or 5 minutes, and then I flipped it over and did the other side. And it's really simple. The heat from the soldering iron transfers into the brass and it makes the brass expand a little bit. And when the brass expands a little bit, that means it gets bigger. And when it gets bigger, then you can put your screwdriver and you can pop it off. So that's how you would typically do that. One of the other things that I show in a lot of the Chime videos is when you're putting back on a brass cap that has a split in it and it tends to be really loose, which means that the plunger, when it strikes, has the ability to pop it off and then you lose it down the heat vent in your house. What you do is you put a little dab of super glue around the tube, and then you press the brass cap back on, and that holds it in place. But of course, if you have to take it apart, how do you do that? And the simple answer is you do it just like I showed you with the soldering iron. If you heat up the brass where the super glue is, the super glue gets soft and then you can pry it off. So there's one thing, that's a tip for you. The other thing about this is it has to do with the actual plunger. So this has inside, there's a single spring and then the plunger and another spring at the other end. And again, there's a video about these and with the lengths of the springs and the length of the tips and so on and so on. And I will link that in another pop-up right here so you can take a look at that. One of the things I wanted to show about this, because it's a good opportunity, is this plunger. Let's put it in the middle where you can actually see it. Like that. This plunger is very different than early plungers. Again, if you go back and look at the K35 Chime video, you'll see it's very different. Traditionally, almost all early NuTone plungers, it's always a metal rod of some kind like this, and the older style ones, 30s, 40s, 50s, and into the 60s until maybe the mid 60s or so, maybe late 60s. There's a hole drilled in each end, and then there's a small plastic tip that's inserted into the hole, and that makes the plunger tip. And it would be as if, we'll open this up here, this is a piece of tip material that we use to make replacement tips. So this would be inserted into the hole in the end of the plunger, and then the way we do it is we trim it to length and shape the tip into a point so it works properly. But this one from 1976 is different, and I get calls about this from people because they have broken tips and they don't know what to do. So these tips, the white one on the left and the white one on the right, these are not inserted into holes in the plunger itself. These are actually molded onto flanges on the ends of the plunger. So to illustrate that in what will be obviously a very crude drawing, I'll show you how that works. So here's the plunger. And instead of holes being drilled on each end where the tips are inserted, as part of the metal plunger, there's actually a flange like this and like this. That's part of the metal plunger. It would have been machined that way or however it was that they made it. And then at some point when this was done and this was made, then it was probably put into some kind of mold and then molded around this flange. The flange is this part and this part. Molded around it would be the plastic tip, like that, and like that. So they're molded, the plastic is molded over the flange. And I assume this was done this way because it was probably an automated process, that some machine did this, and it required less labor to make it because you didn't have people putting tips into holes and gluing them into place and making sure they were the right length and doing all those sort of things. So it was probably a cost and labor saving issue. The problem with this design is, and I think I can show you on this one a little bit, it's going to be hard to see, so we'll try to hold it up. But if you look really carefully on the flange part right there, let's see if I can rotate it a little bit. So right in the front, in the center, you might be able to see there's a small crack that's started. And so what happens is the crack is right here. And over time, if it gets worse and worse, eventually the plastic will crack and break away, and then the tip falls off. When that happens, I don't know any way to repair this, because I don't have the ability to mold a tip back on here. I suppose if we were really super industrious, you could cut the flange off that's part of the plunger and then drill a hole down the center and then put a regular tip in it. But that would be a lot of work, and I don't know if we're ever going to do that. So I just thought I would point that out, because we do get people that have these where the tips break off, and then, you know, parts for these, generally speaking, parts for this kind of chime base, very hard to come by. It seems as if either people keep these forever because they like them, or if they replace them for whatever reason, because it's such a simple design, they don't see, maybe they don't see a lot of value in it and they just toss them away. I don't really know. But these just don't come along to buy up very often. So, you know, if you have one, take care of it, don't lose it, or whatever. Anyway, I thought it would be interesting to show some of the differences, and also how long NuTone uses their designs. There are other things in other product lines like this also where NuTone used the same basic fundamental design that they came up with for almost forever. A classic example in the Intercom world would be outdoor 8-inch patio speakers. Back in 1961, they came up with a 12 by 12 perforated aluminum grill patio speaker with an 8-inch speaker cone on the back. That was in 1961, and that basic grill was used on all 8-inch outdoor patio speaker stations all the way through the end of 2010. So I think they got their money's worth out of the design and all of that. Anyway, I thought you'd find this interesting. If you do, give it a thumbs up on YouTube, because that helps us just a little bit. There'll be a banner right here that shows you how to subscribe. Go to our YouTube homepage, click on the bell, and when you click on the bell, click on it to receive all notifications. And every time we post a new video, we'll get a notification out to you and you can watch it. Also, on our YouTube homepage, you can click on the community tag. And the community tab is a place where I post usually pictures or scans of catalogs and other things, or photos that people send me and stuff like that of their NuTone equipment or other things that are interesting. And usually there I write some kind of wanky description and tell something about what I think it's all about. And you can leave comments and things like that. So if you have something to share, you can always get a hold of me in our email address and send it to me, and I'll post it and give you credit. See ya.